Hello reviewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Starship 2021. So let's dive right into it. Well, Starship that we are talking about is just an outline. You have to understand that there is no, like, even if you hack into Elon Musk system or SpaceX system, you won't find Starship complete design. There is no such thing like that. Now, what they have in terms of outline is first fully reusable. They are very successful with Falcon 9. Now they are like, okay, that has only one flaw, that the second stage is use and throw. They are like, okay, let's make that. So that's their aim. Start with that. That's their aim. Then they are gonna utilize Raptor system. Now why Raptor? Well, Merlin engine is good, but it does have some consequences. Primary consequence of being it utilizes kerosene that inherently is destructive to the engine. That's why, like, new Falcon 9 is brand new white color, and then it starts to become basically blackish after a few use. So, and not to mention, the engine requires an independent thing for ignition. So that does work. They have been successfully using it, but they had enough accidents, and not to mention, you do not want to have extra parts. If you already have an electrical system for your rocket engines, why not just utilize that electricity to ignite the system? So the ignition system is also improved. So Raptor is the code. They have been developing Raptor behind the scene for much longer. So Raptor is much further along. So they're like, okay, this is the data point of Raptor, and this is what I want to do. How can I do a design? This is like almost like Kerbal Space Program level, where they're like, okay, this is what I have, physics, real wise. Let's try to make something. So that's how they know what they want to do. So they're like, I want to have two stage, I want to have at least let's say 300-ton to Earth orbit. That's how they have. But the moment they start to do, okay, how I'm gonna do that, like that, this can be done, physics is saying go, engineering is like, oh, we cannot actually do that. So that's the whole point. That's why their timeline and designs does not mean that much. For example, in 2016, they were launching in 2020. They came up with the idea of basically interplanetary transport system, ITS. Now this puppy was capable of 300 tons to low Earth orbit, but again, can it be done? Yes, physics was like, okay, you can do that, but you have to use let's say carbon fiber. Now they figured it out, they can make it. They actually built a physical tank on it, and then they realized it's like it would be too cumbersome. Basically, the amount of money they will spend to building custom jigs, the amount of money they will spend trying to manipulate this puppy would be too high. So they started to come down, and then they had BFR. The scale was reduced. September 20, till this point they are still using carbon fiber. Then the BFR was remodified with landing legs and all that jazz. This was like September 2018, and then they came up with Starship because they realized the carbon fiber are idiotically expensive. So they are like, thou shall not use that. Then stainless steel was selected. Then in that designs have been changed, because see, they started with independent landing legs, then they had wing that is acting as a landing leg. Now they are back to independent wings and independent landing legs. So basically full circle. So that's the reality of it. They had just rough idea. Even if you directly hack into basically SpaceX system, you will not find anything else. Like, they will only have option A, option B, option C, and they might be parallelly working on all three options. So be very mindful. When somebody says Starship, does not mean it's a complete system. Even though they are actively building on it, it does not mean it's at a point where it's like, this will be the Starship. It could change drastically. So let's understand the core difference between this puppy and every other space agencies. Well, other space agency will not touch a single lump of metal unless they have completed design. That's the core difference. For example, SLS, it has been delayed a lot. Now here's the deal. If you go back as in like 10 years, 15 years, and you look at the design of SLS versus SLS that has been physically made right now, it's exactly the same. What happened in 15 years? Then nothing. They're just doing the same thing. So that's how every other national space agency works on. Basically, be it ISRO, be it NASA, be it JAXA, whatever have you. Now, same will go for even SLS. SLS, I'm saying basically Vulcan from ULA. ULA designed this rocket, and they will not touch metal unless they have finalized every single last detail of this puppy. So basically, the renders they show, the final would be almost identical. And if the render is bit different compared to final product, that would be like that internal CAD model was not used for the rendering. That's the only difference that could happen. Now there is benefit of utilizing this method. It saves a lot of raw materials. For example, what happened to the raw material that was used for early variants of Starship, where the design was inherently wrong? It's like, this, we're not gonna use that, metal is too thick. Again, waste of material. But if you are thinking, okay, that makes this designs better, no, it does come with a consequence of ludicrously inflexible build. What does that mean? That simply means once you have done the design, once you have got it approved, you're stuck there. For example, it's not the first time the space shuttle got, like, people were like, dude, your o-ring system does work, it does work, it did launch, it was, but it's way too vulnerable. Like, one point of failure you have because of the o-rings, and then you had one bad day where the temperature, or bad night when the temperature dropped too much, o-ring shrank, rocket fired, and then you started having a hot exhaust coming there, and boom. So could they have changed it? They had to change it afterward, but they could not have figured this out simply because of their pipeline approach. It's like, dude, once the design is done, do not touch with it, do not iterate on it. But SpaceX is completely different on that. Now, SpaceX does pay the price of it. It's very risky, and you can see that in most of their Starships, boom, kaboom, kaboom, boom, like four of them. So reality is, it is risky, but it does give them quick progress. And the core benefit of it allows them much higher optimization at the other end. And recently Tim Dot did a very long interview with Elon Musk, and Elon Musk talked about something, and that thing back then, when he actually realized that, was the prime reason why he flat out destroyed every single space agency on this planet. Like, literally, you take every single space agency, they're like, bitch please. Like, I'm not talking about payload, I'm talking about rocket side. Payload, again, there are many companies that will make SpaceX bitch please, but in terms of rocketry, SpaceX is like, bitches please. Okay, so that's the one thing he said. Okay, when I'm building Falcon 1, basically it does work, it's a system, we build the engine does work, everything is awesome. Why the heck do we want to use second type of engine? But like, here's the, every company just does that. Like, for example, ISRO has PSLV engines. Now these engines are idiotically ancient, and they are like so ancient, they are from the V2 era, where you have to have a liquid tank, as in like actual water tank, injecting into the some hot parts of the engine so it does not melt. That's still being used in India. And I'm like, what the hell? Like, and Elon Musk was also at the same point where he would have done almost something similar. It's like, stage 1 has this engine, stage 2, but he had a light bulb moment. It's like, you want to repeat as many code base as you can, simply because if you have one code base that has been repeated multiple times, if you fix this one, make it this perfect, everything else becomes perfect. And that's what he realizes. Like, I do not need to have two different engines on my two different stages. And that was the moment the end happened for ULA, Boeing, Lockheed Martin, every other company that even tries to make a rocket. That's the thing. And you can still notice that ULA still has not learned the lesson, and that's why their system has different engines, while every new startup that is coming is like, I shall figure out how to make one good engine, and then I'll just optimize the nozzle for vacuum. The end. Go home. Sweet dreams. And that's the most amazing aspect of Elon Musk. It's like that fact that it's like everybody is doing does not make it right. It just makes that was the right approach back in 1970, not anymore. So that big spark was the reason why he's so far ahead. And you can easily notice that every startup that is coming along now, they're like, yeah, we're gonna use the same engine for stage 1 and stage 2. Every organization that is not doing that will go bankrupt. So that's the difference behind it. Everything is just an outline, and everything is trying to be as optimized as possible. Then let's look at the interesting aspect of the heat shield. Now, heat shield is very interesting because that was the weak link of space shuttle. And I'm not talking about like the accident that happened, that remove that part, because that, I don't think that could have been prevented any way other way. But this was the biggest weak link, as in like it took way too long to refurbish. Now, why it took so long? Because every tile is coded as in a tile number V070-321-575-365. You may be like, why the hell it has so many numbers? Yeah, that's the whole point. It's exactly coded to this exact place. That's it. Like, this tile was manufactured in a company with exact CAD modeling, exact forging equipments, and they're like, this tile will go exactly here, and it has to be done with exact every single time. So problem was, it was way too tedious to verify, it was way too tedious to repair, way too tedious. I'm talking just on the ground, not even in space. There was nothing could have been done in space, and I'm pretty sure nothing can be done in space about this puppy also. But you see that because of that, the cost was ridiculously high. This part alone was like, almost, some people say like it all costed almost the same as the whole space shuttle, because this was so tedious, expensive, and time consuming. So what Elon Musk is doing is like, none of that. It's like, let's gonna use hexagon, and we're gonna tile it as quickly as possible. Now, benefit of that is, once you figure out the hexagon, once you figure out that one hexagon, you'll like mass produce it. You're gonna build a factory and you're gonna, hey, give me 50,000 of that hexagon. That's it, done, go home. And even if you, let's say, some cases it does happen, like let's say lightning strike happens, or let's say bird strike, or whatever have you, you have a scenario where on the pad it got destroyed, a few tiles got cracked. You're like, okay, drill it here and throw it away. And yes, they have to drill it because this clamps, you see, it has been welded on the steel side. Then they put the wool, and then they put basically this tile, and this tile, once they plonk it there, they cannot pull it out again. You want to have a secure system. So if they have to replace a tile, they have to basically drill from the outside. They have to destroy the tile to remove it. They cannot remove the tile non-destructively. So they have steel, they have a wool that is going to act as a basically secondary backup, because there is a lot of gap between the heat shields. Now I'm like, why there is gap? Well, this is one advantage of space shuttle. The gap was almost surgically controlled. Basically, this whole unit acts as one giant system. Each of them will act independently, so they have to give much larger gap. Benefit, cheaper to make. Side effect, it does have a consequence if the load on the backup heat system. Now again, this is not backup as in like it's gonna like handle in case tile fails. This backup as in like leakage heat. So this puppy will handle, let's say, 1 megawatt of heat. The leakage heat would be, let's say, 500 kilowatt. They can handle that. So again, these things are not finalized yet. Once they launch it, once they go through the atmosphere at maximum reheat, then only they will know, will this work or not. So at this point in time, it's a very rough guess, and they still have only able to reduce it. This hex style is not used everywhere, especially in the nose cone. Now I'm a bit confused. It's like, why they are still using hex? They could use pentagons. Like that's how you see a football. You have basically hexagons and pentagons. Mixing both of them, you could cover any complex surface. I'm not sure why they are not doing that, but again, of course, they will have good reasons for that. But you can see, like he's talking about, like nose cone requires a lot of custom hexagons. Again, compared to space shuttle, it's like space shuttle 100% custom. Elon Musk's case is like 10% are custom. Other 10% are a bit iffy, like these styles are specifically made for these locations. And then you have mass production. So yeah, compared to space shuttle, it's much more efficient. But they have not reached that 100% mark where there's like, no, everything is mass produced. And there are still some gaps. You have to understand this aspect, as in this heat shield is not complete. The design is not complete yet. So they do have that's why like they detach the system. Even if you launch it at this point in time, only out of luck it could survive the re-entry. Right now it will not have a success in re-entry, because there are some places where they cannot do basically ceramic heat size because they are way too fragile. So they are still working on that out. It's like some designs, like Elon Musk specifically saying, like, what if we bleed methane there, that could act as a cooler gas buffer. Again, they have to sort it out. The design is just rough. Like core design has been done, the core testing still has to be done, because re-entry is only done in re-entry. So they have to still go through some situations. Now let's understand the landing aspect of it. Now landing, they want to use launch tower. Now why is that? Well, utilizing mathematics that they have done, utilizing the logic of Falcon 9, they know for a fact that if they remove landing legs, they improve the tonnage capacity by a lot. And be mindful, that's why I specified Elon Musk can claim 150 tons to low Earth orbit or even 100 tons to low orbit, does not mean he's gonna actually hit that mark. Once you like, science can say that, but engineering may be like, dude, we need to have this redundancy, we're gonna have to this backup and this and all that. You may end up in a scenario where it's like, no, not really, we can barely end up 70. So reality wise, is like, the more tonnage you remove from the lower systems, the more efficient the rocket becomes. So there's like, what if I remove the landing legs? Now rocket does become lighter when it's coming down, because most of the fuel is gone, and this is just a fancy flying fuel tank. So okay, basically this winglet I'm saying, basically grid fins are strong enough that at a lighter propellant load, as in like the tank is almost empty at that point in time, they should be strong enough to sustain the complete load of the rocket, and they should be able to catch it. Now that's their aim. Now primary reason for doing that is A, weight reduction, and B, cost. Now cost is very important aspect of it. It's like, there is no point of building a Starship, it's too goddamn expensive, and at this point in time there is no demand for Starship. And even if SpaceX completely builds it, how many countries exist in a place right now where they're like, no, I want to send 100 ton to low Earth orbit? Be mindful, the biggest unit sold to basically ISS was around 13 tons, one unit 13 tons. So there is no need for this. Now SpaceX have the need in terms of basically Starlink organization, where they're gonna have like hundreds of satellites, 400 satellites upwards of. So for their point of view, they can use it, but they still want to improve the weight and cost. And it does come with a consequence. They will risk the launch pad, and he was talking about that very thoroughly. It's like, I do not want to, like, if this is the launch pad, I want to catch it like the, no, I want to catch it here. So if the launch pad is here, the main clamping unit, the rocket will try to come here, and then, so even if it fails, even if, let's say, this grid fin snaps and it falls down, at least the launch mode will not be destroyed. Now you were like, isn't the launch mode strong? Well, it's strong against vibrations and temperature. It's not strong against falling 100-ton object. So that's the difference aspect of here. And they're gonna utilize asymmetric grid fins. Now be mindful, look at it, like Elon Musk himself, all the images from SpaceX itself had grid fins in, like, 90-degree offsets. Now they are like 60-degree mirror offset. Now they are assuming this will help them achieve much higher, greater control. And they are not even folding the grid fin. Why? Because it's removing a part count. Same way removing second stage unique engines by first stage main engines helped them save money. They are doing the same thing here. Now again, after, let's say, they do it, they may find out we have to fold it because at max Q this may end up causing too much issue. And if it can go through max Q without causing too much issue, then they're like, yeah, who cares? That's a like extra hassle to have that folding system. They do not need the folding system. Asymmetry should allow them to grip, and this will also help them distribute load, because if you are at 90-degree apart, how the heck you gonna catch it? You can only able to catch two fins at the same time. Now this way, there is a very greater chance that you at least 3 fins will be caught. Even if, like, rocket is not perfectly aligned, at least 3 fins should be caught, and 4 fins, awesome. So that's the landing aspect of it, and they are still working on it. And that's why the first orbital flight, they will not even try to catch it. They're like, just go to ocean and go splash down. Hopefully successfully reach to ocean surface in one basically unit, and then go boom. Let's understand the production aspect of it. And this is where Elon Musk is truly talking about something very serious about this world. It's like every Tom Dick is like, in lab I have made this battery. It does not mean jack shit. Reality is, making things in lab is child's play. Designing things, even designing rockets, are child's play. Mass producing it, that's a whole different ballgame. And he's like flat out talking about it. Like, a rocket development is like, for us, it's like that's a side thing. Yeah, don't focus on that. That's side thing. Making a factory that can mass produce this, that's the main aspect. Like, there are many companies at this point in time. There are, I think, 25 major corporations that has the facilities to make rocket engines. How many of them can claim they can make 1 engine per day? Almost none. So that's the whole point of it. Factory is the key. And better factory, once they built a better factory, I'm not talking about mass production factory as in like fixed design mass production. So you can, ULA can have that. ULA will like, this is my final design, this is exactly how I'm going to mass produce. They can mass produce that. But if they want to iterate, that factory will end up fighting it back. So they don't want that. They don't want old style of factory where they're like, everything is rigid, everything is fixed, and they're copying out the same design hundreds of time. They don't want that. They want a factory that is very agile, adaptive, and fast. So they can do what we call very high turnaround. They can make mass produce things quickly and iterate also, and that iteration is very critical, because I can guarantee you the grid fin design will change. I can guarantee you many other aspects that you say, hey, that was fixed, they could change. So that's the reality of it. And final design and tonnage, the tonnage that they are aiming for, that could change drastically. They may end up in a scenario where it's like, dude, only 72 tons to low Earth orbit is feasible, and because again, they don't have launch escape system, they would need much higher redundancy to make sure that it's get human rated. So there are other things that they have to deal with. But while even though Elon Musk is working at ludicrously high speed, it does come with a consequence. This approach of changing everything after the fact, or changing things once you realize that is much more better way of doing it, it does take a lot of time. So 2024 is not happening. Even at lightning speed of Elon Musk, it's not happening. That's not gonna happen. Human rating a spacecraft is way too difficult, way too tedious, way too convoluted, and way too long. And I'm talking just the paperwork of it. So fundamentally speaking, even if it is moving at current speed continuously without any issues, without any ups and downs, it will still take at least to 2030 to get it human rated. And again, if they push it really hard, 2027. So this was my presentation on Starship update. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.